Hello everyone, welcome to the ninth video. So this would be one of the most important video of this series because in this video we are going to talk about TF-IDF, which is one of the most important concepts of NLP. So what does TF-IDF stand for? It is basically term frequency inverse document frequency. So you already know about term frequency. Let us understand what the problem of term frequency is. So you might want to go to this place. So and before I start, you would see that I've done a little bit of refactoring around the main function. So make sure you pull the branch from day 8 so that we are on the same page. All right. So you would see that when I'm building the index, I'm just considering scores, file name plus equal to count. So if a word appears more times in a document, it gets more point. That sounds very reasonable. That if we have a query in which I'm looking for some specific words, then the document which has the most occurrences of that word should come up first. But it has a big weakness because some words are common across the whole corpus. So if a document repeats a certain word many times, raw term frequency just outranks it. So like if I can help you explain this with a small example. Let's say we have a TF-IDF demo query. We have TF-IDF demo documents. And for example, the query is system NLP. Now in this system, it is a very common term, but NLP, it is not so common term. So if you pick up 100 books of software engineering, most of the books would have the word system in them, but it does not mean that most of them would have NLP in it because it's rarer compared to system. And if I have a demo file data, which says that common system repetition, and this basically has many occurrences of system. You just copy this system, and then it has maintenance in it. So there is one document as NLP doc, and this document is actually relevant. So it has system NLP language model, and I have one more some doc.txt. This has system database, oops, system database indexing. So yeah, this should be list of this. All right, and these should be the keys. What does it say? It is not defined. Okay, yeah. So if I have a query system NLP, um, which of these documents do you think I should get returned? Obviously, it's the system NLP doc.txt because this document actually has information relevant to NLP. But with our current system, you would see that the document which gets returned is the first one, which basically has literally zero information about NLP. Let us just see it in code. Delete the old index. And what I need to do here is basically I need to create the index again. So and converted index. Okay. I copy this, I paste it here. Copy this, I paste it here. And the search function, I basically copy whole of this. I place it here, copy this, place it here, copy this, place it here. And the query is this one. And I print it. And what I do is basically just to make the code a little bit cleaner. So show sample, show query without TF-IDF. Okay, I should do it like show demo without TF-IDF. I paste what I had and I call this function here, show demo without TF-IDF. Let's see if that runs. So you, as I said, you see that the file which has more occurrences of the word system comes on top because with a score of 9 because the word system appears many times in it, but it has literally no information about NLP. And this is not what we want actually. We wanted the second document to come up, and this problem we are going to solve with TF-IDF. So basically, what IDF asks, IDF is how rare is this term across all documents, and the final score is basically term frequency into inverse document frequency. So in our code, this will be the result token file name into This should be the term frequency into IDF. Okay, we already have the term frequency in a lot of places. We have calculated it, so we need to define a formula for IDF. So I'm simply going to use total number of documents. So it's inverse document frequency. So um, you would say that what is document frequency? It's simply the number of documents which have that specific keyword, and what is inverse of that is you just flip the numerator with the denominator. So let me write the numerator first. So document frequency, and this will be total docs, but we are doing an inverse of it. So I pick this up, I place it here, and this gives me the inverse document frequency. But just for avoiding a division or a multiplication by 0, I'm going to add 1 on both sides here. Plus 1. Also, to make the result a little bit more consistent so that we don't like blow up the result with the scores, I'm just going to apply a long function on it. This basically does nothing but just normalizes the scores a little bit so that it's easier for us to look at. And also, you would see that if a word appears in all of the document, then this document frequency is equal to this total docs, and this IDF, this whole value, it becomes 0 because it becomes math of log 1, which is 0 for any um, which is 0 all the time. And if a term appears in lower number of documents, which means that that specific document has more importance. So this whole value of IDF, it goes higher. So let me see how it comes in our example over here. So we need a function for this, which would be define calculate IDF. And calculate IDF, it is nothing but we need the total number of docs. So total docs and frequency, and I'm just going to return math.log. Um, let's import it. We are going to return the total docs plus 1 by frequency plus 1. Let's wrap this around brackets. Okay, and now what we need to do is basically use this function. So okay, one more thing I can do here is basically if the total docs is equal to or maybe less than equal to, even though it's never going to be negative, 0, just return a 0 0.0 just to avoid the computation being done over here. And what this should return is a float value. Okay, that is done. And now I need to define a function as calculate IDF. What this is going to do is basically take the file data, and it is going to return me a dictionary of string and dictionary string comma float. So this is very similar to what we did before. Yeah, this is basically the same instead of integer over here, which basically was giving us this score. We are going to use a float now. And in this calculate IDF function, like, okay, so this is going to actually be build TF-IDF index. And in this one, I'm going to do a ranked index. First, we need to just build the ranked index normally. So build ranked inverted index, file data. Um, so to call the calculate IDF function, I need the total number of documents. Total docs equal to length of file data. This will give me the total number of documents. And let me just initiate a result. So what I can do now is that for token comma document counts in ranked index.items. Now, what is this? It's basically the specific token along with the document counts. And the document counts over here is basically a dictionary which has the document name and the number of occurrences of, like, basically the score of that token against that specific document. So now we can call calculate IDF and total docs, comma, the length of the document counts. So basically, if I have like specific token, say system, and it has appeared in say this file and this file uh, and this file as well. So the number of times this token has appeared in documents is basically the length of the document, so document count. So we will get the IDF from here, and we can just do a result in this token equal to this, and just initiate it. And now what we need to do is for file name comma term frequency in document count dot item. So now for each of those individual, like we have the pairs, right? Like the document name and the count, document name, document count. So this is actually going to give us the term frequency, and the result for that token, for that specific file name, it is going to be the term frequency into the IDF score, and we can simply return the result from here. Okay, so we have built the TF-IDF index. Let's test this function quickly. So okay, I will create a new function here, show demo with TF-IDF. We are going to print nothing as of now. TF-IDF index equal to TF. Okay, these are some errors of counts and result. Yeah, those were some typos. TF-IDF index, TF-IDF index, and this is the file data for it. Let me just print it. TF-IDF index. We have to import the function. Let's clear. So you would see that now what we have, just a second, we have the TF-IDF demo documents. Okay, print that again. All right. Okay, we were calling the wrong function here. Let me run that again. So yeah, let's ignore this one. It says file already exists at index data.json. We need to remove this. From where is this one coming? Let's quickly see that. Okay, we don't actually need this call here. All right, so you would see that for the word system, in this common system repetition, we actually get a score of 0000. For nlpdoc.txt also we get 0000. Why is this happening is because the word system, it appears in all the documents. So essentially, even if we remove it from the corpus, it does not matter because it does not hold much value, as it does not help us filter out the big corpus of documents we have. Whereas the other word NLP, that is what is important. And if you see about the word maintenance, so common system repetition, it gives a value. If you see about NLP, we have a value here, and language we have a value. So our index is built. Now what we need to do is basically um, use it for searching. So let me just write a function here. Define search df idf index, and what it will take is a query string and a tf idf index. This was the format of a tf idf index. So let's just give it here, and this should return what the other search functions are returning. So we are going to do the same thing, which is first we would want to tokenize it. Okay, we are tokenizing it, and then you are going to see, let us just initiate the scores first. Scores dictionary string comma float equal to empty, and now for each token, for token in tokens, we are going to have the document set, and this is basically going to be tf idf index um dot get. We get the token, and if it is not there, just get a empty dictionary over there for file name and the weight. So this is the file name, and this is the weight. So file name comma weight in doc set dot items. um if the weight, if the weight is, it's not going to be negative, but still, then do nothing basically, because that specific term does not even matter. And if file name not in scores, if that specific file is not even there, so scores file name equal to 0. And what we have is that score, otherwise the scores file name is going to be the weight. Okay, and now we are going to return it. So return the We have to rank it as first. Let me see what was the function we had used earlier. So we had this one. Let me copy it, paste it. So rank docs is basically going to be the sorted of the items. And in this one, what I can do is basically I can convert this and make this into a minus x1, the last value along with x of 0. Reverse equal to true. I don't really need to do that if I am actually doing it. And what I need to return is, okay, so simply return the file name. I need to return the list of dictionary. So the key will be find name doc score. I can copy it. Okay, anyways, let's write it. Score, let's just round it off. The score up to 4 places. Okay, this is going to be list of dictionary. So for document, comma score in rank docs. All right, let us test this function. So we do not need to print it and just do a search TF-IDF index. This takes a query under TF-IDF index. So we have our demo query here and we have the TF-IDF index. Just print the result of this. Let us import it. And now you see that our relevant document, which has the term NLP, only that gets returned. So with this, we have like actually just filtered out the documents which actually matter rather than the documents, rather than searching on the terms which are there in all the documents because it does not really give us anything. So we would need to integrate this in our code as well, like along with the other search methods. And to do that, we need to actually go here, comma, okay, let me do TF IDF, TF-IDF. This is going to be a TF-IDF index search, and in this lambda, what I'm going to take is the in this lambda, what I'm going to take is the query. Let me just copy this and paste it here. This is actually going to be this function now. Search TF-IDF index. So search TF-IDF index q, comma. This is actually going to be the TF-IDF index TF-IDF index, and from where we are going to get it, we are going to make it TF-IDF index equal to build TF-IDF index with the file details. So we will see that everything we are doing here, we are making it constant, so that it's very much similar to the other search methods that we have, just for consistency purposes. And one more method we are going to call here, which is search TF-IDF index with snippets. Now we do not have it, so we are just going to make it. Build TF-IDF index. Here I'm going to add a with snippets, and just we need to import it, but also hold on. So TF-IDF index with snippets. Oh, we actually needed to add the search function. My bad. Search it with snippets, and let's see the other snippets function we had. Yeah, so let me just copy this instead. Paste it here. Copy the name. Paste it here. This is going to be a TF-IDF index now. TF-IDF index. Oh, sorry. Copy this. Paste it here. And this is going to be of the type which is returned from here. Okay, now it should be imported automatically. Okay, and I also need to pass in the file details actually. So I'm passing in the file details in this one. So file details, let me see the other function for which snippets, or we can just open it side by side. That will be much better for us to code with snippets. Yeah. So we have this here. Let's do a word wrap. File details. File details. Okay. And in this one, It's going to be the TF-IDF index.get. It's basically going to be the same as this one, except when we have this result over here, what we are going to do is just look at it. Let me just copy everything from here. I'm sorry, I'm making a lot of copies, but I just need it. I just want to get it done quickly because we already written the code, so it makes no sense to rewrite it again. We just copy it from here and paste this here. And this results, it says we have not initialized it. Let's just initialize it at the top itself. Results. Okay, this should give us the result now. Says we have some problem. The FIDF statement must be separated by new line scopes. All right, and now let's see what our search comparison gives us. So we are going to uncomment this, I'm going to comment this out, or maybe just delete it. We don't need it anymore. We'll delete this. Okay, so demo with TF-IDF. Delete this, delete this. We recreate the index data, and it says it needs 3 positional arguments. So I need to pass in the file data. Let me copy it and paste it here. Okay, so now we see that it is giving us the TF-IDF search results as well. If you look at it, let me just comment out the other results. Okay, so this is the index which was created, TF-IDF, TF-IDF. These are the queries which we have and the method name. And okay, I'm just printing the time. Let me also print the output which I get. So I don't think we are actually using this print results function. No, we are not doing it. I just need to do print results over here, and I can pass in the result. So remove this as well. Okay, yeah, that returns us the results as well. So if I see a query indexing a SQL, it gives a TF-IDF index search, and it also gives me the snippet, gives me the file name as well. So this is the TF-IDF index search, TF-IDF index search. It gives the file name, and it also gives me a score as well. So let's just observe one query. Um, so let me just see this one query. Clear. Now run it. And okay, so our query is operating system scheduling, and what it gives us is the file name operating system process management at top. That is expected because this file has the most amount of data related to operating system. It gives us the score as well. Second we have is the software architecture design pattern and with a score as well. So this tells us that we now also have a score, like a proper score, which is not just an addition to the number of tokens on the number of tokens for each document. This is quantifiable, so we can actually see how well one document is or how relevant a document is with the other document. So you just to wrap the whole video up, we moved today from raw counting to weighted ranking, and this raw term frequency, what it asked was how many times this query term appears. TF-IDF asks how many times it appears and how special is that term across the corpus. So this is why the rare query terms have more weight. And also we proved the improvement on by using this demo example, that before the demo this term was not relevant at all because the system term was basically overriding or like giving more score to the output, which is not even relevant because this is in all the documents, so it does not matter if we take it or not. And so yeah, that's it for TF-IDF. And the next one we are going to improve this further with BM25, which actually fixes some TF-IDF weaknesses around long documents and term saturation. Thanks for watching and see you in the next one.